On the right hand side, you can see I just have an iOS project. And then on the left hand side, I simply have the terminal running Claude Code. So this is a prompt that I have created, and I'm just going to run it and see what it comes up with. So this prompt right here is regarding writing tests for this project. At this very moment, there are no tests written for the project, so having some tests would be handy. Okay, it is running. As a matter of fact, I would have it run another loop simultaneously. So this would be regarding accessibility. So let's see how Claude performs. And yeah, so you might be asking, like, what's the difference between just running a normal command without the loop versus one with the loop? So regarding with a loop, it's kind of self-explanatory in the sense that with the loop, you define a goal, but then you don't really tell it like what exactly to do, and it will figure it out continuously, and it will continue to like verify itself. Whereas if you run it with just the command itself, it will just like run it, but it won't continuously iterate itself until it hit the goal and know how to check properly all the time, at least, right? So it is just a much more purposeful way of writing software with AI. But you know what? I think it'd be interesting to see what Claude explains. So now we are just asking Claude, explain to us what's the difference. Like, why should we even use a loop in the first place? Okay, so here is Claude's answer regarding just prompting, which is like the default mode. When you type a request, it does the job. It stops, one turn, one outcome. But if you prompt the loop, essentially, the user will review what the Claude has done, the AI has done, the agent, then decide the next step. So this means that the agent does 95% of the software engineering work, from writing to editing to debugging to refactoring to answering questions and anything where the user wants to inspect each result before continuing. So in a sense, it is iterative, and the user gets to steer the process constantly. With a loop, it reruns a prompt of slash command on a repeating schedule or self-paced until the user stops it. The interaction, the same instruction fires over and over across turns without you needing to typing in. So essentially, like, less work on outside. And I think what happens is that, by default, like it's mentioned right here, if you don't mention a certain interval, then it will just decide it. It will self-pace, choosing when to wake up, etc., etc. And in a sense, it is similar to like a cron job, essentially, without the need to like babysit all the time. I guess another great use case for it is if you have long running processes, such as type test suite, fixing failures into green, some practical use cases. essentially, I think with a loop, you want to use it when something takes more than one prompt, and you want the AI to go through the process instead of you having to go through the process. Like that is the whole point of it. So essentially, if the result is the same every single time, you just use a normal prompt. But if the result can be dynamic, perhaps if you're doing something even like related to like the stock market, any kind of tasks where it is just that very dynamic in nature, that a loop comes in a lot more handy than what it is right now. So I think that pretty much explain it. You need something to be like dynamic and reoccurring. Then that is when you use a loop. And you don't just force a loop down the throat of Claude Code just because somebody say loop is so cool right now. It will change your life forever. And let's see if these prompts are warranted as loops. Okay, the AI say they both qualify. A loop earns its place with each iteration, produces a different result, and the task converges to a terminal state. So you do need a terminal state, which is like the end state essentially. So each cycle will pick up a new unit or screen and output the first at each iteration. So it's not reprinting the same thing over and over again. And each loop essentially has like an explicit stop condition. So that's important. Again, back to the terminal state. Each listed core unit has passing tests. So every primary screen audited and fixed once. And each of the iteration per se has a per cycle verification gate. And for us, with this prompt, it is regarding the test passing before landing or rebuilding green plus a re-screenshot essentially. So yeah, so each of the iteration has an escalation clause, so the agent doesn't just silently guess on some kind of ambiguity. Okay. So yeah, it's saying, it's the right shape, and it's a poor fit for a single prompt because too much to be done in one pass and to do it well, and as a result, you will lose the incremental green checkpoints that keep the blast radius small and each change reviewable. Yeah, I think this makes a lot of sense now, like regarding why you want to use a loop. Essentially, if there are some kind of process that is kind of long, you have to have an end state, of course, and you have to be verifiable, throughout the process. So you're kind of thinking about think about it as like a line, right? And you want to get from point A to point B, and at each point between those 2 points, there's like smaller steps, and this is when you can use a loop. So for us, regarding like writing the test, this is a prime example. Now let's look into the second example regarding the loops. Okay, wait. Before we go that, there's something this want to mention. It says one nuance to be aware of. These are work queue loops, not pull external state loops. Neither wait on anything outside the session. No CI, no deploy. The state that changes each cycle is changed by me. So the schedule wake up time machinery is mostly vestigial here. Hence, there's no reason to sleep between cycles. And we'll just keep working until done or until it hits an escalation. The value that I am getting is the per cycle protocol and stop condition, not time-based polling. So it's saying there's also a feature, so to speak, to do with time-based polling. Let's say you have another external service. Here it mentioned the possibility of using some kind of CI/CD pipeline or service. So with that, you don't necessarily have a real-time update on when something will be done. So that is when polling comes into play, and it mentioned it. So that's also another way to use loops when you have more than a single entity at play, and you have multiple dependencies, multiple services working together. And if you want to link them all up together and have them work together, I think the loop is a phenomenal way of doing that without having a person's supervision all the time. You basically have the AI agent be its own supervision and be its not only for itself but for other services as well. Okay, so now we're looking at the per prompt caveats. You have test hardening for the loop one. Okay, it's saying it's strong, low risk, 2 nodes. Record coverage added per cycle needs a real mechanism. So Xcode coverage in the test scheme, otherwise coverage becomes hand waving. Worth confirming the scheme has coverage gathering on. The verification gate is objective, test pass, which is what makes this loop trustworthy. Alright. Now for the second prompt, or should I say the second loop prompt, we did the accessibility hardening. It also mentioned that it is warranted, but we are softer in the verification. Some audits aren't deterministically checkable the way passing tests are. Okay, fair enough. And let's see why it's saying that. So regarding the color contrast issues and tap target being greater than or equal to 44 points, judged from a screenshot, are unreliable. Contrast needs computed ratios. Tap targets need measure frames, not eyeballing. I would lean on inspecting Swift UI source using the frame font accessibility label rather than the screenshot for those, and use the screenshot only for the layout regression proof. Proof no layout regression via before or after screenshots is the right idea, but a visual diff by eye can miss subtle shifts. Good enough for hardening pass, just note it is not airtight. So for both of them, yes, loop them. Loop 1 is the cleaner of the two because its gate is objective. For loop 2, expect to make a judgment call on the fuzzy criteria and learn on the source inspection over screenshots where measurement matters. So there you have it. So the better you are able to make an objective verification during a process step, the more hard the verification process becomes. So hard as in like being intact and deterministic. Whereas perhaps if you are talking about like, as I mentioned, with the accessibility, something where if you take a screenshot and you kind of just like eyeball it without having like empirical hard numbers, like the contrast level, right? Like between two colors, let's say like you have like a background and text on top, are those two colors when placed on a screen strong enough regarding the contrast to fit the criteria of, for example, an 811Y requirement for what is visible or like highly visible. So many things to think about, but at the end of the day, with a loop, you have a beginning state and you have a desired state, and there are many small steps in between. Some of them haven't easier time verifying the steps, and those are the ideal scenarios, here being unit tests as an example, whereas something much more subjective, such as looking through a screenshot through an eyeball, whether something is considered quote unquote accessible, an example with color contrast, those are a bit more subjective and makes the verification softer. So with a softer verification, it is just a lot less deterministic, but nevertheless, it will still work. So yeah, I think these are two very interesting examples. And let me see if they have, give me one more, yeah? Give me one practical use case. Let's see what it gives us if we ask for one more practical use case. Okay, so now it is talking about the Crashlytic triage loop for post-release. So this is regarding just running a loop to check out the Crashlytic for new and then crash clusters. Each cycle pull the top crashes by event count and affected users since the last check. For any cluster that's new or newly spiking, map the stack trace to the responsible Swift source. That's define severity and if the root cause is clear and low risk. Write a minimal fix on a branch and open a PR referencing the issue. For anything ambiguous or high blast radius, escalate with one exact question instead of guessing. Skip clusters, already triage this session. Stop when no new or spiking clusters remain. So why is this a quote unquote textbook loop? It is not a one-shot prompt, okay? State genuinely changes between runs. So new crash land as root users hit 2.1.1. So rerunning produces different data each cycle. This is the polling case that plain prompting can't cover. Convergent condition, no new or spiking clusters, quiet release, loop winds down on its own. Then it has the verifiable per cycle output, where each fix is a scope PR you review, and not a blind auto merge. And there's also a cadence to it. For this one, it's looking at 30-minute matches, like how fast crash data actually accrue. It's tightening, falling, just burn tokens on in change dashboard. Okay, so basically with this, it's basically like after, let's say I release this app, it's going to just keep polling and check for any post-release crashes, and it will more or less do a triage and do a diagnosis for a fix. Yeah, so with this loop, it helps us ensure that all of our UI elements are accessible, because a lot of these UI elements are essentially like custom UIs and they don't get accessibility features out of the box by default, which is why this could actually be quite helpful, right? So we have a bunch of screens, asking it to go through each screen and do its thing regarding accessibility and making sure that it is doing what it's supposed to do to make an app accessible to our users. Okay, I think that is all for today regarding the video. I hope you have learned something very helpful regarding loops and when you might want to have it in your process whether you are building software or doing anything in your day-to-day life, that is much more than just a single prompt away to having your answer. So there you have it.